Components: Arduino Uno, USB A to B cable, breadboard, LCD with I2C module, LED, resistor of 1K ohm, buttons, male to male and male to female wires, crocodile cable, speaker. Take a breadboard, connect 2 push buttons on opposite sides of the breadboard. Place an LED on the breadboard and add a resistor in series with it. Connect the ground pins of both buttons to a vertically shorted line on the breadboard. Next, connect the VCC pins of the buttons to another vertically shorted line. Connect the digital output pin of the button used for dash to pin 6 on the Arduino. Connect the digital output pin of the button to pin 7 on the Arduino. Now connect 5 volts from the Arduino to the VCC line of the breadboard. Finally, connect the ground from the Arduino to the ground line on the breadboard. Begin with an LCD equipped with an I2C module. Attach 4 female-to-male jumper wires to the I2C module's pins. Connect the SEL to the A5 analog pin and the SDA to the A4 analog pin on the Arduino respectively. Link the VCC pin to the 5V pin of the Arduino. Finally, connect the ground pin to the Arduino's ground pin. Take speaker. Connect left and right section of 3.5mm jack to red crocodile cable and ground section to black one. Clip male-to-male jumper wires to the opposite ends of each crocodile clip cable. Connect the jumper wire from the red crocodile clip to digital pin 3. Attach another jumper wire from the ground crocodile clip to the Arduino's ground pin. The code begins by including necessary libraries. Wire.h for I2C communication, liquid crystal I2C.h for LCD control, and the Talkie library along with different vocab files to generate speech. It initializes the LCD with the address 0x27 for a 16 by 2 screen and sets up the Talkie object to produce speech. The dot and dash input buttons are connected to pins 7 and 6, respectively, while a single LED is connected to pin 9 for visual feedback. Morse code timing constants are defined. Letter pause time and word pause time are used to determine the pause durations for letter and word spacing, respectively. A D-bounce delay of 200 milliseconds is set to avoid multiple button detections. An LED dot duration and LED dash duration control how long the LED lights up for dot and dash inputs. 2 strings are initialized. Morse input to store the ongoing Morse code input and decoded message to accumulate the decoded message. The Morse codes array stores the Morse code representations for all letters and numbers, while the letters array holds the corresponding characters. The say letter function is responsible for converting each character into speech using the Talkie library. It uses a switch statement to map each letter or digit to a corresponding speech command. The say message function iterates through the decoded message string, calling say letter for each character. The setup function configures the button pins with internal pull-up resistors, LED pin as an output, initializes the LCD, turns on the backlight, and starts serial communication for debugging. In the loop function, the program continuously checks the states of the dot and dash buttons using digital read function. If the dot button is pressed, it appends a dot to the Morse input string and triggers a short LED blink. For 200 milliseconds, a similar process occurs for the dash button, with a longer blink duration for the dash. To avoid multiple detections of the same button press, each button has a debounce mechanism that prevents new inputs until the button is released. Once the word pause time threshold is exceeded, the program considers the input as a complete word. It displays the entire decoded message on the LCD and speaks it using the say message function. Afterward, the decoded message is cleared and the program waits for the next input. This project holds immense importance as it bridges a crucial communication gap for speech-impaired individuals. By converting Morse code inputs into both text and speech, it empowers users to express themselves effectively, breaking barriers of isolation. The inclusion of an intuitive interface with visual and auditory feedback ensures ease of use. This innovation serves as a stepping stone toward enhancing accessibility and inclusivity, offering a powerful tool for speech-impaired individuals to engage in meaningful conversations with those around them.